Hello guys, this is the third video of the chapter Amines. So in this video we'll be discussing Hofmann bromide reaction or Hofmann bromination. Right, till now we have discussed about two methods of preparation. The first was alkylation of ammonia, in which we saw there was a drawback that we get a mixture of primary, secondary and tertiary amines, right? But now we'll be discussing about, and then after that we discussed the second method of preparation, that was uh, the Gabriel synthesis, in which we got only primary amines as the products of the reaction. All right, and now it's the time for third method of synthesis, that is Hofmann brominide reaction. All right, Hofmann brominide reaction, and in this method also we get only primary amines. So it should be noted we get only primary amines here. Fine. Now let's check about let's check how this happens and what is the mechanism of the reaction. Let me say there are three steps of this reaction. It should be known there are three steps of this reaction. The first step is formation of N-bromoamide from amide by the action of base, and in this reaction we take base as NaOH. Fine. It is the first, and then also Br is also present. So by the action of these two, what we get is this product. It's the first step of the reaction. The second step of the reaction is conversion of N-bromoamide to isocyanate. Fine, to isocyanate. I know my handwriting is a bit dirty, but hope you can understand that. Let me write it here. Isocyanate. This is what we get as a product of first reaction, right? From an bromoamide. This is the reaction. Fine. So this is the reaction. This is the second step. Let me say in the third step we form RNH2. In the third step, let me also write that down. In the third step, there might be spell mistakes which you should be knowing about, and pardon me about that. So in the third step, RNH2 is formed, right? RNH2 is formed along with carbon dioxide, H2CO3. We can say that, right? This is the third step in which this product is formed from this. Fine. So let me also write now the first step. Let me erase it. Fine, let me write it down. The first step is amide to, what we get is isocyanate and bromoamide, right? And bromoamide. This is what we get in the first step. It's the first step. This is what we do in the second step, and this is the third step. This is the first, this is the second, and this is the second, and this is the third. Fine. So these are the steps of the reaction. Now let's try to understand what is the mechanism and how it proceeds. So fine, let's take the first step of the reaction. The first step is something like this. We take an amide, that is this, RC bonded with O. This is an amide. Fine. Here you have H, here you have H, and here you have double bond on oxygen. Let's draw this carbon full. Fine. Plus Na positive is furnished by NaOH, and OH negative is furnished from the same, that is NaOH. Fine. Plus we have Br2. Fine. Now what happens in the first step of the reaction is that this OH extracts this proton from the amide. This is the amide. Just let me write it down here. AMID. Fine. Now what happens is that this proton is extracted and this bond pair is converted into the lone pair of electrons on nitrogen. So what we get is something like this. R C double bonded with oxygen. Here we have N, here we have a negative charge on nitrogen and two lone pairs and H on the lower side. Fine. This is it that has formed. So this polarizes this Br bonded with Br and it extracts Br from it, and this Br is released as Br negative. So what we get is this. This is the RCO and Br. Here we have H and a single lone pair of electron on this nitrogen. Plus we have NABr. Fine. How that will be formed? This Br, it will be forming bonds with this nitrogen, this sodium. Fine. And also water is formed by these two. Fine. Hope you understand that. So what we have got is NABr plus H2O. This is the first step of the reaction, and this, let me say you, this is the N bromoamide. All right, so this is the first step of the reaction. Fine. I know the spell is wrong. I don't know how it is wrong, because I know only this spell. I don't know any other spell about bromoamide, but whatever it is, let's keep the error as such. So here you go. From amide we have prepared, see, from amide we have prepared and bromoamide. Fine. This was the first step of the reaction. Now let's go with the second step of the reaction. The second step is formation of isocyanate from N-bromoamide. Fine. Let's deal with the second step now. So what happens in the second step is that we have this R, that is the N-bromoamide, sorry, CO, N, here Br is present. Fine. Here H is there and a double bond on nitrogen, plus there is OH negative from the NaOH from the base, right? And Na will be also present, Na positive. Let's draw that on this side. So this OH negative this time extracts this proton, and this bond pair is converted to the lone pair of nitrogen. Fine, we get something like this. So we get R, C, O, N, two lone pair of electrons on this nitrogen and a negative charge, and Br. Fine. Now you have to understand how the rearrangement takes place. Here you can see, let me show it. So this bond pair is first converted into this this lone pair is converted into the first bond pair with carbon, right? So this is the first step. Just write it down, 1. Fine. So now after this, since this carbon has got 5 bonds, simultaneously this bond will be breaking and this R will be leaving. This is also 1, because these two processes will be occurring simultaneously. Carbon cannot have 5 bonds at a time. So it's not like first this bond is formed, then this bond is broken. These two things happen. The formation and the breakdown, they happen simultaneously. Now what happens is that this R comes into this nitrogen. This is the second step, fine, in this rearrangement, and this Br leaves. Fine. Here you can see also this Br also leaves simultaneously, though this is the second as well. So what we got is something like this. Let me draw it in red. Now R will be connected to nitrogen, which will be having a double bonds with carbon, which already had double bonds with oxygen. Fine. This is isocyanate. Plus what we have got is Br negative, which will be bonding with this nitrogen, this sodium, and it will be forming NaBr. Fine. It will be forming Na. Just let me erase this Br, and it will be forming NaBr. Fine. Sodium bromide. This is the product which we are not concerned about. This is the product that we are concerned about, and it's called isocyanate. Let me write it down here. Isocyanate. Fine. This is the product of the second reaction. Fine. Now you can see that we have done the 2 steps of the reaction. That is, the first was the formation of N-bromoamide from amide. The second was N-bromoamide to isocyanate, which we have also seen how that happens, right? Now let's go with the third step of the reaction. Let me write that down in green. So here is the third step of the reaction. Now we have not formed the product yet. That is, our primary target is the formation of the primary amine. Let's see how that forms now. In this step that will be formed. Let's see how. So what happens is that this R N double bonded C double bonded O, it's now taken in the third step, plus OH negative from the base again is there, fine, plus we have Na, which will be furnished by the same NaOH, right, Na positive, fine. Let's see what happens further. So this OH negative, it will be attacking on this carbon, and simultaneously this bond will be converted into the lone pair of this nitrogen, which already had a lone pair of electron, right? So let's see what is there now. So we got something like this: R N double bond with two lone pairs of electrons at a negative charge, and C, which has O at H on one side and double bonded oxygen on the other side, fine. So here you go, here it has two lone pair of electrons. Now what happens is that this oxygen, it takes these lone pairs and converts them, it takes these bond pairs and converts them into their lone pair, and this nitrogen donates its electrons to this hydrogen. It's not this hydrogen actually that happens, but for simplicity purposes we say this hydrogen. It can be any hydrogen that is present in the medium, right? So what we get is, we get something like this: R N H, which comes to this nitrogen, and here we have C bonded to O negative, fine. It has 6 electrons and a negative charge developed, also this oxygen, fine. Now what happens is that this oxygen converts its bond lone pair into bond pair, and simultaneously this bond is broken down. This already had a lone pair of electrons, which I forget to draw, I don't know why. So what we get is something like this: R N, it has two lone pairs of electrons now and a negative charge and hydrogen, fine. Plus what we have got is CO2. Here you can see, fine. Plus what we have in the medium, what we have is water, right? That is H and bonded with OH, fine. Now this will be extracting this proton, nitrogen. So what we get is RNH2, the primary amine, that was our product of concern, plus OH negative, plus CO2, which both of them, which can be said as HCO3 negative, fine. And here we have the primary amine. This is our product of concern, which we got to know. So this is the third step of the reaction. Now let me summarize the things for you. Here you can see we have converted this isocyanate to this molecule. Sorry, here you got to write, not, I have written it wrong here, SCO3 and a negative charge. I don't know how to write. All right, so now you can see. All right, so SCO3 positive, this is developed. SCO3, sorry, not positive, negative should be here, type O error. So this is what we get, fine. Here you can see. So this is the third step of the reaction. Let me conclude the things for you. The Hofmann bromide reaction, it has 3 steps. The first step is the conversion of amide to N-bromoamide. The second step is conversion of N-bromoamide to isocyanate, fine. And the third step is conversion of isocyanate to primary amine along with HCO3 negative, fine. These are the 3 steps of the reaction, and in the first step we do the process by action of base, and then Br is again added at this nitrogen and we get N-bromoamide. In the second step of the reaction, again base acts and it extracts this H positive, this 9, and a negative charge is again developed on nitrogen, which undergoes rearrangement to form isocyanate. All right, and then the third step comes into play, where OH negative again acts on carbon, and what happens is, this time what happens is, also let me say it to you, Here you can see it's an acid base reaction, because H OH and this H OH is extracting H from the right, H from this molecule, that's amide. In the second step as well, you can see this again an acid base reaction. Why? Because again OH is extracting H positive. In the third step, you should be knowing it is not an acid base reaction. So we can say this one is not an acid base reaction. The first two steps are acid base reaction, but this one is not, right? This should be taken into consideration fully. Fine. So what happens is that we have gone, here is the third step. Fine. So here is the third step now. So what happens is now that OH negative acts on this carbon and gets attached there. So OH is there, fine. In the second step now, hydrogen is released. You should be seeing this here. So this hydrogen is released as H positive, and this nitrogen takes that hydrogen here, you see, and this oxygen now converts its lone pair to bond pair, releasing carbon dioxide plus this negative charged N with R group. Fine. Then this negatively charged N extracts proton from medium, that is water, and we get a primary amine. Here you can see there, by no way we can say secondary amine is formed or a tertiary amine is formed. So these are not formed in this reaction, that is Hofmann brominide reaction. Only primary amines are formed. Fine. So take to the primary amines. That's all about it. Make sure to subscribe to the channel Chemistry Cracks in order to get more videos like this. Thank you for watching. Goodbye.